So let's also take a look at our options for revolving. So we now actually have a new dedicated slicing mode called Revolve, which I'm not using in this case because it's very new, so new that I haven't created a workflow for it yet. But we have this kind of cylindrical object here. This is essentially just a bowl. So we have this, and to slice this, it needs to actually be non-planar, because if we sliced it horizontally, the step overs here are going to be massive, and it's not actually going to print properly. So we need the layers to be smaller here, and also it needs to be directional with the bowl itself. So we can do that using our non-planar slicing mode, and we can use some guide meshes to do that. So non-planar works with guide meshes. So depending on the geometry, you can either select surfaces or you create guide meshes in CAD. I can show you a more conventional non-planar use case later as well. So let's lock that. So the first guide is actually this cone here, and that's at the tip of the bottom here. And these meshes are being used as guides for the slice, but also the tool orientations. And then the other guide is this circle here. So this is fairly a bit more obvious as to how it's working. It's just a flat circle. So the shape of the bowl, it's flat. So the layers at the top are going to be nice and flat. And we can actually, with those, CAD options in the software, this is essentially how the non-planar slice works. It will tween these meshes as guides. Of course, much finer than this, but you can see how our layers are going to kind of gradually conform to horizontal, and they'll start smaller here. So in our slice operator, we can pick non-planar. We pick our two guide meshes. We also have non-planar infills. We can add more walls. We can do all sorts of fancy things. So you can see that our layers at the bottom are actually much smaller.
Yeah. And that's one way to do it. We still have the compensation on the full cantilever to go still horizontally if we need to close to fully print on an overhang.
Yeah, I think in that case we'd use the segmented slicing mode, and that's kind of our own version of like a geodesic type slicer. And that would be a case if you have this bowl where you needed to close it off on top as well. So it would slice much like this, and then the layers would come inwards as well, which is very fancy indeed. And then
more challenging toolpaths because physics play. Physics starts to become a reality here. But yeah.
And then here, I mentioned we can manually set our tool rotations and tool positions. So with the edit operator is where we do that. So we can set tool rotations, and we can do a number of different things here. We can set them to specific value. We can have them smooth around each other, orient it, rotate it, orient it on a mesh. Or in this case, I'm doing a revolved incline. So I know the part is cylindrically symmetrical. We can rotate it on this bed. If your print bed or external axis isn't able to do a continuous 360, which some aren't, then we can work around that. So for example, we can use a filter operator like I used before, but this time by every nth layer. So what that means is here is I'm filtering every second layer. So if I put 3, it'd be every third, 4 every fourth, and so on. And I can reverse the direction of that. So let's take a look at it now, because as it is now, it will just do a continuous revolve if you've got a print bed where it can just keep spinning around, which is a nice luxury not everyone has. So we can filter half the layers, reverse the directions. You can see they're all pointed to the right before, now they're all pointed to the left. And then once we combine those together, you can see that they are going back and forth. So the bed will spin one way and then back the other. So we can utilize or work around those hardware limitations as well. In this case, I think we're just using the classic constant 360. turn off that travel travel line, doing a dance around. So we can see the bed is just rotating underneath. The tool is almost kept fixed. It's just moving up and slightly out as the part prints. That bed is rotating. It's all nice and automatic.
Yeah.
And also, when I looked at the edit operator earlier, because this is a Fronius system, in this printer config, we will have enabled process parameters. So we can actually change our process parameters here. And if I use a new edit operator, we can see, if I just do it on anything, that we can call a different process ID. So for a Fronius controller, they're job IDs. For other technologies, it could be anything else. So we can, as long as it's something that you can call in the toolpath, we can refer to it here. So for wire arc, it's often the case that, say, on your first layer, you're using one set of welding parameters. On your following layers, you use another set of welding parameters. On weaves that connect to other weaves, the end of that weave, you need a different welding parameter. So we can isolate all these different regions, filter them out, do whatever we need to do, give them their different job IDs or welding parameters or whatever thing we need to call. And it will, in the toolpath during printing, call that and make that change.